Hello and welcome everyone. This is Mohammad Inzamam from SAIMEDHA State Coaching Center, Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing free of cost YouTube video lectures for previous ESET examination questions from the effective faculties of SAIMEDHA Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, mechanical, civil and computers. For all the branches every single day we are updating PYQs, previous ESET examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, SAIMEDHA Koti Hyderabad is giving the coaching for online ESET 2024-2025, offline ESET 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్ న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, SAIMEDHA Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. SAIMEDHA Koti Hyderabad lo coaching anedi first year diploma నుంచి స్టార్ట్ అయిపోయినాయి, సెకండ్ ఇయర్ డిప్లొమా స్టూడెంట్స్ కి స్టార్ట్ అయిపోయింది, థర్డ్ ఇయర్ డిప్లొమా స్టూడెంట్స్ కి స్టార్ట్ అయిపోయింది. 3 years కోర్స్ ఉంటుంది, 2 years కోర్స్ ఉంటుంది, 1 year కోర్స్ ఉంటుంది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో SAIMEDHA Koti Hyderabad is providing every year coaching. రిజల్ట్స్ విషయానికి వస్తే యు నో ఇట్ గైస్, ఎవ్రీ సింగిల్ ఇయర్ టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై SAIMEDHA Koti Hyderabad ఓన్లీ. So my dear students, what are you waiting for? ESET 2024, ESET 2025, ESET 2026 coaching has been started in the SAIMEDHA Koti Hyderabad. ఎఫెక్టివ్ కోచింగ్ ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్ ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ as ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in SAIMEDHA Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
Hello everyone, welcome to SAIMEDHA Koti Hyderabad. In this session I would like to discuss about previous year questions of ESET in the concept of DC motors such as classification, speed control, starting, braking of the two DC motors. And let's start from the question number 1. A separately excited DC motor is supplied with a constant field current and constant armature current. So when the armature voltage is 500 volts, it runs at 960 rpm. If the armature voltage is reduced to 450 volts, its speed is neglected armature resistance. Option 1, the 912 rpm, the 1000, the 67 rpm, 960 rpm and 464 rpm. So mentioned in this question the separately excited. So this field winding of the DC motor is excited with the separately. So this is the field current IF, okay, and this one is the field flux of the machine, okay, this one is the Φf1. Now armature of the DC motor, so assume this is the armature equivalent circuit. Now it is excited with the DC supply. So now this is the supply voltage we have and their armature resistance, but this drop is neglected and this one is the back EMF of the motors, okay. This is now this is the equivalent circuit of the separately excited DC motor. So given in this question, given that this armature voltage, okay, when armature voltage the E1, so when the applied voltage V1 is equal to 500 volts and the speed N1 is equal to 960 rpm, So this is the one statement. And next one is applied voltage reduced to 450 volts. So when applied voltage V1, the 2 is equal to V2 is equal to 450 volts. Now this is the speed of the motor, and IA RA drop is the neglected. Also mention that IA RA drop is equal to the 0. Now we know the during operation of the any DC motor, okay, during operation of the any DC motor, the back EMF directly proportional to the product of the field flux and the speed of the motor. So this field flux is a constant, okay, constant, as okay this one is. So because it is independent of the applied voltage, because it is a separately the excited the DC motor, okay, separately excited DC motor. So it is extremely constant. So when it is a constant, this back EMF EB is directly proportional to the speed. Now from here we can get the speed is speed N2 by N1 is equal to the EB2 divided by EB1. So now if voltage drop is neglected, the V2 by the V1. So therefore N2 is equal to N1 is the 960 RPM and V2 is equal to the 450 volts, the divided by the 500 volts. So by solving this we can get the 864 RPM. So that answer for this question, the option the 4 is correct. So if it is shunt motor, okay, if it is a shunt motor in the question, answer is a 960 RPM. Why? Because in the shunt motor, as applied voltage reduces in the same proportion, the field flux also reduces. So if it is a separate excited motor, this field flux is extremely constant. That's why this speed is directly proportional to the back EMF. If the voltage drop is neglected, armature resistance drop is neglected, it is directly proportional to applied voltage. So answer for this question, option the 4 is correct. And next let us solve question number 2. The direction of the rotation of the DC shunt motor may be reversed. So interchanging the positive and negative terminals of the supply voltage, or reversing the both armature and field current connection, decreasing the bad torque and reversing the either armature or field winding connection. The direction of rotation of the DC shunt motor can be reversed by reversing either armature winding terminals or field winding terminals, but not both. So that answer for this question, option 4 is correct. And next one, let us solve question number 3. During the starting of the DC compound motor, so compound motor means it may be cumulative compound or differential compound motor, the series field winding is shorted to prevent the excessive copper losses, damage to the series field and saturation of the field current running with a high speed in the wrong connection. Now in order to prevent the motor from high speed in the wrong connection, it is a shorted. So that option the 4 is correct for this question. And next one, question number 4. In case of the DC motor is connected across AC supply, so option 1, the motor will run at rated speed, the motor will run at the corresponding synchronous speed, motor will run at the slow speed. So that option the 4 is correct for this question. Just like the DC series the single phase induction motors. This one option next one, question number 5. If a DC motor is to be selected for conveyors, which motor would be preferable? This one is a shunt motor, series motor, differential compound motor and cumulative compound motors. So one of the application of the cumulative compound motor is used in the conveyors. Why? Because cumulative compound motor has adjustment of the speed torque characteristics. So now this is a option 4 is correct for this question. And next one, question number 6. The ratio of starting torque to the full load torque is least in case of the series motor, compound long shunt motor, compound short shunt motor and the shunt motors. Okay. Suppose let us draw the characteristics of this characteristics of the all motors. Suppose this one is the torque and this one is the torque speed characteristics of the DC motor. So this is a no load torque of the motors. Okay, this is the no load torque. So now this is a no load, or this is the speed in this case, okay, speed point of view, and this one is the torque. Okay, this one is the no load speed, and this is the speed in this case, and here these are the characteristics for the differential compound motors. Okay, differential compound, and this one is the shunt motor. Okay, this one is the DC, the shunt motor, and the speed torque characteristics. Now these are the characteristics for the series motors. Okay, series, and these characteristics in between these. Okay, this in between that shunt and series motor. So these are the cumulative compound motors. So cumulative compound motors point of view. So now in this case, the differential compound motor. Okay, this is the starting torque. Okay, suppose starting torque means, so this is a per low speeds. Okay, this is the series motor has high torque. Okay, this one is the start. So now starting torque divided by the full load torque. Okay, this is the full load torque. So now starting torque is per low speeds. So here this is the starting torque. This is the rated speed. Okay, this one is the rated speed condition. Now then what will happen? Series motor has highest this ratio. Starting torque by full load torque is the high in case of the series motors. Okay, this one is the series motors part. Now next one. So here least pace is the differential compound motors. Now this one is the least. So here starting torque by full load torque is the low in case of the differential compound motor. So after the differential compound motor, this one is the DC shunt motor. So in the option there is no differential compound motor. So that's why. So which option is correct? Shunt motor is the correct. So if the differential compound is mentioned, that means, so first one it is a maximum, after that cumulative compound, after that DC compound, and least one is the differential compound. So there is no option, this is the differential compound. So next motor is a DC shunt motor. That's why option 4 is correct for this question. And next one, let us solve question number 7. The speed of the shunt motor can be increased. So by increasing the resistance in the field winding and increase the resistance in the armature winding. Option 3, decreasing the resistance in the field winding, and option 4, decreasing the resistance in the armature winding. So speed of the DC shunt motor can be controlled above its rated value by using the flux control method. So in flux control method, some value of the external resistance is inserted in series with the field winding. So that's why answer. So increasing the field resistance in the field winding. So as the field resistance is increases, series field the resistance is increases. So what will happen? So this field current IF is decreasing. When IF is decreases, the field flux also decreasing. When field flux is decreases, we know the speed is directly proportional to the back EMF and inversely proportional to the field flux. So change in the back EMF is almost constant, the constant in the flux control method. So now decrease in the field flux increases the speed of the motor. So that's why the speed of the motor can be increased. So by inserting some external resistance in series with the field winding. So that answer 1 is correct for this question. And next coming to the question number 8. The question 8 is a starter is used in a DC motor because it is not self-starting. The initially back EMF is 0 and armature current is I, and it is necessary to overcome the back EMF. Its resistance is very high. The purpose of the starter, okay, to limit the starting current. So now that means at the time of the starting, okay, this at starting. So now that means speed is very nearer to the 0. So when speed is nearer to the 0, so what will happen in the back EMF? Back EMF directly proportional to product of the field flux and the speed. When speed is equal to 0, so therefore back EMF is almost equal to 0. When back EMF is equal to 0, what is the armature current? Ia is equal to the V minus Eb by the Ra value. So when this value is equal to 0, so V by Ra. So for example point, so V is equal to 200 and Ra is equal to 0.1. So now this is the 0.5. So then what will happen? So let us take one more 0.1. So now here the Ia is equal to the V by, so this is the Ra. So V is a 200 divided by 0.1. So now this will become the 2000 amps. So now which is very high. So this one is a very high, which is a more than the more than the rated current, which may damage the winding of the DC machine. So in order to limit this current, in order to limit the armature current to a safe value, the starter is required. So that initially back EMF is a 0 and armature current is high. That's why starter is used in the DC motors. So that option, the 2 is correct for this question. And next one, let us solve question number 9. If the field winding of the running shunt motor is suddenly breaks, field winding of the running shunt motor suddenly breaks, its speed shows down, it stops at once, it gives the sparks, it speaks the speed dangerously high. So now here mentioned that DC shunt motor, the field winding is suddenly breaks open. So now let us see in this case, suppose we have a field winding. So this is the field winding of the DC shunt motor. In the DC shunt motor, armature winding and field winding are connected across. So now this is the supply is the armature supply. So now here V and this one is the supply of the DC shunt motor and this is the I amount of the current and this one is a shunt field winding. Okay, this is the ISH value. So now in this case ISH. Now we are in this question mentioned that so field winding is a open. Okay, this one is a armature current. So to solve this question, so first we need to verify whether torque is present in the motor or not. So now let us verify the first one. The step 1 what we have to do. So first verify the torque. Okay, verify the torque in the motor. Okay, that means the verify the driving torque of the motor. So let us verify the driving torque. Next one, step 2. So if torque is present, okay, this torque is present. So then the verify the speed. Okay, verify the speed of the motor. So if the step 3, if torque is equal to the 0, okay, this torque, then motor come to the stop. Motor comes to the stop. That means there is no driving torque of the motor. So that means that there is no driving torque. Definitely it comes to the stop. Now let us verify the torque in the motor. So now if the field winding is open, suppose this field winding is open. So field winding is open, then what will happen in this motor? So here field current, shunt field current is equal to 0, but this flux is there is a flux is not equal to 0. So flux will become okay, residual flux. Now it is a very small, so that is the flux is reduced to very small value, okay, very small. And what about this armature current? I is equal to I amount of the current. Now let us verify first step. Now this one is the torque is directly proportional to the flux and armature current. So now torque directly, this flux will become pi r and armature current here. So therefore by using this what I conclude, the torque present in the motor, what are present. So when torque is present, okay, then what we have to do, verify the speed. So speed is directly proportional to the back EMF and inversely proportional to the field flux. So here torque is directly proportional to the back EMF and flux is inversely proportional to the this speed is inversely proportional to the this field flux. So this field flux is reduced, it is almost constant. Now it is reduced to the very small value, okay, this small value. The speed of the motor increases very high. So the speed of the motor increases very high, that is the dangerously high speed. Under running condition, if the field winding of the DC motor is suddenly open, then what will happen? The speed of the motor or the DC shunt motor that rotates at dangerously high speed. Okay, how do we solve this one? So for this type of the question, first we need to verify the driving torque of the motor. So if the driving torque is present, then verify the speed of the motor. So don't consider initially the speed of the motor. So first one, we need to verify whether driving torque is present in the motor or not. So if there is no driving torque in the motor, definitely it comes to the stop. So if driving torque is present in the motor, it rotates at some speed. It may be greater than the rated speed, or less than the rated. So it depends upon the value of the flux. Here flux is reduced to very small, so that speed increases to very high. So answer for this question, the speed of the motor becomes dangerously high speed. Okay, and next let us solve question number 10. The direction of rotation of the DC motor may be reversed by reversing the supply voltage and adding resistance to the field current, the reversing the armature current, interchanging the armature and field connection. So now direction of rotation of the DC motor can be reversing by changing the armature winding terminal or by changing the field winding terminal, but not both. So that answer in this question are reversing the armature current. So now armature connections. So option the 3 is the correct for this question. Got it?
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous ESET examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. అడ్మిషన్స్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app SAIMEDHA.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in SAIMEDHA Koti Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.